Hello everyone and welcome to Abaqus FEM. In this video, I am excited to introduce our complete welding simulation package in Abaqus, a comprehensive training program that includes 16 practical workshops covering some of the most important and advanced welding processes used in engineering and research today. You can see it here. Welding is one of the most widely used manufacturing technology in industries such as aerospace, automotive, shipbuilding, energy, defense, and heavy machinery. However, welding process involve complex thermal, mechanical, and material interactions that can significantly uh, affect the quality and performance of a structure. Uh, Engineers and researchers often need to predict temperature distribution, residual stress, distortion, material flow, and joint performance before conducting expensive experiment tests. This is where finite element simulation become an extremely valuable tool. The purpose of this package is to help engineer, researcher, graduate student, and Abaqus user learn how to simulate various welding processes accurately and efficiently using advanced numerical method. Here you can see the overview of the package here. Let me briefly introduce the topic included in this package. The first group of the workshop, as you can see here, focuses on the friction stir welding, commonly known as FSW. These workshops include the simulation of ABS polymer, friction stir welding here, friction stir welding, friction stir spot welding using oily method. Here you can see friction stir welding using couple Eulerian Lagrangian for aluminium SPH method and then for a steel model. Uh, the second group focus on the impact welding and high-speed joining uh, processes. This workshop demonstrates the simulation of impact spot welding and axisymmetric impact welding, allowing users to investigate large deformation, high strain rate, and collision-based joining mechanism. Here you can see these two. The third group covers water jet spot welding simulation. In these workshops, you can see here, both the coupled Eulerian Lagrangian approach and conventional Lagrangian approach are utilized to investigate the interaction between high pressure water jet and metallic plates. This project provides valuable insight into fluid. You can see this two here. Uh, Localize the formation and advanced joining technology. Next, we move to one of the most important industrial welding method, arc and fusion welding. Several workshops here are dedicated to arc welding simulation of a steel plate and pipe using DFLUX subroutine. These projects focus on moving heat source implementation, thermal analysis, stress analysis, and residual stress prediction. You will learn how to develop and apply user-defined heat flux model, perform thermal and thermomechanical analysis, material-dependent temperature, and distortion and residual stresses. Another exciting part package here is explosive welding. You can see these two examples here. Two dedicated workshops investigate explosive welding between titanium and steel pipes, as well as copper and aluminum pipe. Explosive welding is one of the most challenging joining technology to simulate because it involves extremely high strain rates, several plastic deformation, and complex material behavior. In addition to learning a specific welding process, this package also introduced several advanced numerical techniques used in modern finite element simulation. You will gain practical experience with the ILE method or CEL method, SPH, dynamic explicit analysis, thermal transient analysis, DFLUX subrouting, and some else. These techniques are widely used in industrial and academic projects and are essential for advanced welding simulation. Now, let's talk what you will actually receive after purchasing this process or this package. Sorry, this package. You will receive complete Abaqus CAE file for all workshops, allowing you to explore and modify the simulation model directly. You will receive input file, which are especially useful for advanced user want to study the numerical implementation details, and and all required source codes and DFLUX subrouting. In addition, you will receive detailed step-by-step video tutorials explaining every stage of the simulation process from geometry creation and meshing to analysis, setup, execution, and result interpretation. To help a user understand the uh, theoretical background, relevant research paper, and scientific reference are also provided. By completing these workshops, you will learn how to create professional welding simulation, define realistic heat source, perform thermal and thermomechanical analysis, investigate residual stress, evaluate distortion, and analyze material flow. The package is suitable for mechanical engineers, welding engineers, manufacturing engineers, graduate student, PhD student, finite element analysts, and anyone interested in welding analysis. Uh, if you would like to learn more about the package, explore detailed workshop description, or see sample result, please visit our website, Abaqus FEM. And thank you for your attention. And sorry, I forgot the payment method. The price of this welding full package is 127 euros. And uh, we accept PayPal, Visa, MasterCard, and all the cryptocurrencies. Before payment, contact us through this email to tell you more about anything that you want to know of this package. This package is really good for anyone who want to learn all welding method in Abaqus during 16 workshops. Thank you.